What if I told you that more than 5 million engines from GM, Toyota, Honda, and Hyundai are failing right now? Some of them catching fire with families inside? $70,000 trucks dropping dead at 30,000 miles. Dozens of fires, multiple injuries, and manufacturers working hard to keep the truth quiet. Your engine could be next, and here's what they don't want you to know. Start with the numbers, because they should shake every car owner watching this, and your vehicle might be on the list. General Motors recalled around 720,000 vehicles for its 6.2-liter V8, and that's barely the start, with roughly another 280,000 now under federal investigation. GM has logged more than 28,000 complaints, over 14,000 of which ended in complete engine failure and total loss of power, along with the reported 12 injuries and 42 engine fires. Not overheating, not smoke, but actual fireballs under the hood while people were driving their Silverados, Tahoes, Yukons, and Escalades. Then there's Toyota, the brand built on million-mile reliability myths, which recalled roughly 102,000 twin-turbo V6 engines in 2024 and then quietly added more than 100,000 in late 2025. We're talking brand new Tundras, $90,000 Lexus LX 600s, Sequoias, and hybrids still under investigation. Honda recalled around 250,000 of its famed 3.5-liter V6 engines for rod-bearing destruction. And when those let go, metal shrapnel tears the engine apart at thousands of RPM. Worse, regulators reportedly opened a probe into more than 1 million additional Hondas going back to 2016. And Hyundai and Kia have recalled roughly 1.5 million engines since 2017, with some of the replacement engines failing in the exact same way. Add it all up and you're looking at more than 5 million engines, and by some estimates, nearly $8 billion in damage. This isn't a recall. It's an engine failure epidemic, and it's getting personal. So what's actually causing it? In December 2025, Automotive News, a publication usually friendly to automakers, dropped a bombshell investigation. They talked to university engine researchers, independent mechanics who've torn down hundreds of failed motors, and industry insiders who would only speak off the record. What they found is devastating. Modern engines are being pushed far beyond what they were ever designed to handle. Automakers are chasing record-breaking horsepower per liter, numbers once reserved for race cars, running temperatures that would have melted older engines and cylinder pressures once seen only on drag strips, all packed into engines half the size they used to be. Consider the scale. In the 1990s, a 6.0-liter V8 made about 360 horsepower, roughly 60 horsepower per liter. Today, Ford's 2.7-liter EcoBoost makes around 325 horsepower, about 120 per liter. And the 3.5-liter EcoBoost in the Raptor pushes 128 per liter. That's double the power density, the same stress with half the metal to handle it. And to hit EPA and CAFE targets, manufacturers keep switching to thinner and thinner oil. What used to be 5W30 or 10W40 became 0W20, then 0W16, and even 0W8, a fluid barely thicker than water. Thinner oil might save half a mile per gallon, but it demands tolerances measured in microns, meaning the machining, cleaning, and assembly all have to be flawless. As Professor Greg Davis of the University of Michigan Flint puts it, higher pressures create greater bearing loads and accelerated wear. In other words, automakers are demanding the impossible, and physics is finally fighting back. There's also an invisible killer quietly destroying these engines that almost no one outside the trade knows about. It's called swarf. Dave, a master engine builder from Dave's Auto Center featured in that investigation, explains it well. Swarf is the microscopic metal debris left behind during machining. When manufacturers cut, drill, and hone an engine block, the big chips are easy to remove. But the ultrafine particles left from honing the cylinder walls are the deadly ones. Honing creates a slurry of metal dust, abrasive grit, and coolant that he compares to concrete, brittle, razor-sharp, harder than the bearings themselves, and sticky enough to cling to every surface. If even one microscopic piece works its way between a bearing and the crankshaft, it behaves like sandpaper at thousands of RPM, embedding into the soft bearing and then grinding into the hardened crank. Minutes later, you get scoring. Hours later, metal on metal, and within days, total failure. Dave's team spends hours cleaning each engine by hand, with hot tanks, pressure washing, compressed air, and scrubbing every passage 5 or 6 times. But GM builds something like 10,000 engines a day per factory, and Toyota, Ford, and Stellantis are no different. Hand-built perfection at that scale is simply impossible. So automakers lean on automated rinses and quick visual checks and hope for the best. Powertrain tester Tom Howell sums it up: thinner oils, tighter tolerances, and harder bearing materials are all feeding the failures. Harder bearings mean less forgiveness, less ability to absorb debris, and almost no margin for error. It's a house of cards, and it's already collapsing. And swarf and thin oil are only the beginning, because what's really happening isn't one design flaw or one bad batch. It's a pileup of modern technologies and engineering compromises all hitting at once. And stacked together, they make long-term survival nearly impossible. Take the start-stop systems almost everyone hates, and for good reason. Every time the engine shuts off at a light and restarts, oil pressure briefly drops to zero, and with ultra-thin 0W20 or 0W16 oil, the protective film left on the bearings is tiny. Cold starts already cause most engine wear, and now drivers rack up 40 to 50 start cycles in a single commute. It's why fleet trucks that pile on 150,000 highway miles in 2 years often outlast personal trucks with 50,000 city miles, because they escape that relentless stop-start abuse. Then there are the variable displacement oil pumps. Older engines use simple, predictable fixed pumps, but new ones rely on computer-controlled pumps constantly adjusting pressure, and if one lags after a start-stop cycle, misreads temperature, or malfunctions, your bearings get starved. More complexity, more failure points. Turbocharging makes it worse, with cylinder pressures over 2,000 psi, roughly double a naturally aspirated engine, and turbos spinning at 150,000 to 200,000 RPM that depend entirely on clean, correctly weighted oil. Any contamination or delay in pressure shreds the turbo bearings and sprays metal through the whole engine, and a single turbo failure can kill the entire powertrain in seconds. Direct injection adds its own stress, firing fuel at 2,000 to 3,000 C straight into the chamber, which is great for efficiency, but brutal for longevity, raising combustion pressures, leaving carbon to build up on valves with no fuel to wash them, and pushing temperatures higher against an already thin oil film. On top of all that, the engines built from 2020 to 2022 came out of chaotic, pandemic-era factories with new unproven suppliers, missing quality inspectors, and skeleton crews. GM wrestled with out-of-spec rods, Toyota admitted contamination issues, and Stellantis even found sand trapped inside engine blocks. And those engines are now reaching 60,000 to 100,000 miles, where the hidden defects finally surface. Finally, there's cylinder deactivation, turning V8s into V4s to save fuel, which sounds clever, but creates uneven temperatures, uneven block expansion, and shock loads every time the dormant cylinders snap back under load. Stack all of it together and the truth is unavoidable. Modern engines aren't failing from one problem. They're failing from 10 at once. And no engine survives that forever. If you're finding this helpful, take a second to hit that like button and subscribe to support the channel. Here's where it gets genuinely suspicious. The part manufacturers don't want the public to see. Independent engine builder Eric Berg spent 3 years just trying to get his hands on a failed Toyota twin-turbo V6 because Toyota aggressively bought back every blown engine as a core exchange, keeping them out of independent shops and off YouTube. When he finally got one, the teardown was explosive. The main bearings, the ones holding up the crankshaft, were destroyed, shredded, scored, and heat burned, while the rod bearings fed by the very same oil circuit were pristine, with no wear at all. If debris or contamination were the cause, Both should be damaged since they share the same passages and the same oil. Only the mains failing points to one thing: a design flaw. Maybe the oil passages are too small, maybe the clearances are too tight, maybe the bearing material can't take the load. But a design flaw is far more expensive to admit than manufacturing debris. Look at Hyundai's Theta engine disaster, where they blamed debris, recalled 1.5 million engines, replaced them, and watched the replacements fail the same way. That's not dirt, that's design. And here's the real tell. GM's fix for its 6.2-liter recall is switching from 0W20 to 0W40, twice as thick. If thin oil wasn't the problem, why is thicker oil the solution? Because they know the tolerances are too tight for thin oil to protect these high-pressure engines. But admitting that means lawsuits, billions in costs, and regulatory backlash. So they blame debris, while the engines themselves tell the truth. So who's really behind all this? The answer is bigger than any single automaker. It's CAFE, the corporate average fuel economy rules that set the average miles per gallon every manufacturer's entire fleet has to meet. And those targets have grown aggressively unrealistic. The requirements were set to climb roughly 8% a year, then 10%. Aiming at a fleet average near 49 miles per gallon. Meanwhile, your F-150 gets around 20, your Tahoe sits near 18, and your Corvette around 16. There is no mathematical way to reach a 49 mpg average with traditional engines, and the penalties are punishing. Historically, around $17 per vehicle for every tenth of a mile per gallon a company falls short. A manufacturer selling 2 million vehicles and missing by a single mile per gallon could face hundreds of millions in fines. So they squeeze out every fraction they can with tiny turbo engines, thin oil, microscopic tolerances, start-stop, and cylinder deactivation. Anything to dodge the penalty. Engineers didn't forget how to build reliable motors. What changed is the regulatory pressure pushing designs past what's reliable at mass production scale. The automakers ran the math and decided a predictable rate of failures is cheaper than missing the standard. Your engine's lifespan against their compliance, and they chose compliance. And it's about to get worse. Yes, the administration rolled back some CAFE standards in 2025, and you'd think that would ease the pressure and help reliability. It didn't. What actually happened is that EVs were pulled out of the fleet average calculation. Before, manufacturers could count EVs at the equivalent of 200 to 300 mpg. And those huge numbers offset their gas guzzlers, so a company could sell thirsty F-150s, Expeditions, and Mustangs, and let the Mach-E and Lightning balance the books, even buying credits from Tesla. Not anymore. EVs no longer count, but the fuel economy requirement still exists, only modestly rolled back. And now automakers have to hit it without EVs to offset their trucks. That leaves three paths for your next truck. They can go to even smaller engines with even thinner oil and tighter tolerances, pushing the limits further into more failures and more recalls. They can slash power, so your next F-150 might drop from 400 horsepower to 250, and your Silverado might tow 5,000 pounds instead of 13,000. Or they can hybridize everything, putting a battery and electric motor in every truck and SUV, which means more components, higher prices, more things to break, and battery degradation dragging down resale value. And they aren't walking away from EVs either, having sunk billions into those platforms and knowing standards could tighten again. So they'll keep reaching for the same strategies that caused this mess. More than 5 million failed engines, billions in damage, with Hyundai alone reportedly facing around $5 billion. And nothing fundamental is changing. This isn't just about recalls and statistics. It's about your money, your safety, and your family. These failures are hitting vehicles that cost as much as a house, an $80,000 Silverado High Country, a $75,000 Tundra Turd Pro, a Lexus LX 600 over $100,000, a loaded Escalade around $120,000, with engines dying at 30,000 to 40,000 miles, sometimes less. Owners keep posting fresh main bearing failures on trucks barely a year old. Picture it. You save for years, finally buy your dream truck for $70,000, sign up for $1,200 a month, and 6 months later you're driving your kids to school when you hear knocking, then grinding. Then the engine seizes and you coast to the shoulder, terrified. The dealer confirms a full engine replacement, It's under warranty, but the replacements are on a 2-month back order, so you keep making $1,200 payments on a truck sitting dead in a service bay. When you finally get it back, you own a nearly new truck with a replaced engine and gutted resale value. Because who wants a 3-year-old truck that blew its engine at 30,000 miles? Some owners try lemon laws, but many states exempt vehicles under recall, so the manufacturer says it's fixing things and you're stuck, remembering all the while that Hyundai's replacements failed the same way, because the design itself was flawed, and the safety side is worse. GM logged 14,000 complaints involving complete loss of propulsion, engines dying mid-drive, plus those 12 injuries and 42 fires. 42 engines that caught fire while people were driving their families. Toyota reports stalling and loss of power. Honda's rod-bearing failures send metal fragments tearing through the engine at thousands of RPM, and a rod can punch straight through the block or the hood. A Hyundai Palisade recall even warns that a broken valve spring can blow a hole through the engine. These aren't minor annoyances, they're life-threatening failures in vehicles you trusted with your family. The good news is that you can protect yourself. The first move is to check your VIN right now at NHTSA.gov using the Recall Lookup tool, and if your vehicle shows up in a recall or investigation, schedule the repair immediately, because these failures often strike without warning. Find one day and destroyed the next. Next, cut your oil intervals roughly in half. Ignore the 7,500 to 10,000 mile recommendations and aim for 5,000 at most, or around 3,750 if your manual calls for 7,500, since an extra $50 to $75 a year in oil changes is nothing next to a $15,000 engine or a $70,000 truck turned worthless. And use a high-quality oil in the correct specification, something like Mobil 1, Pennzoil Platinum, Valvoline, or Castrol meeting your engine's required spec. It also helps to disable start-stop, pressing the button every time you drive, and if your vehicle resets the setting, a $50 to $100 OBD2 device can shut it off permanently, costing you maybe 0.2 of a mile per gallon while sparing you dozens of needless wear events a day. Once you're out of warranty, you can consider stepping up one oil grade, so a Subaru running 0W16 might move to the 0W20 that's allowed elsewhere, or you might run 5W30 now that GM itself has gone to 0W40 on the 6.2 liter. Just don't go to extremes, one grade at a time. Keep an ear out for new ticking, knocking, or rattling. Check your oil every 1,000 miles, and watch for low oil pressure at a warm idle, which is a red flag. Be smart when buying. 2. Avoiding first-year redesigns and steering clear of 2021 to 2024 model years on the used market, since a proven 2015 to 2019 naturally aspirated V8 with 100,000 miles may well be safer than a 2023 turbo with only 30,000. And for a 2020 to 2024 used vehicle, a $2,000 to $3,000 comprehensive warranty covering the engine internals can save you from a $15,000 to $20,000 replacement, as long as you read the fine print and confirm it covers bearing failures. Do these things and you'll dramatically improve your engine's odds of surviving this industry-wide mess. Here's the bottom line. More than 5 million engines are failing because manufacturers chose regulatory compliance over your engine's survival. This isn't bad luck. It's a calculated gamble with your money. Has your engine failed? Drop your story in the comments and let's expose this together. And if this was helpful, smash that like button and subscribe for more auto content. Thanks for watching, and I'll see you in the next video.